Hello everyone. This is a fourth video on inferential statistic. In this video, we discuss statistical hypothesis. In particular, we understand how to formulate a statistical hypothesis, what exactly mean by hypothesis testing, and steps involved in hypothesis testing. We start with the definition of statistical hypothesis. Statistical hypothesis is a statement concerning about the parameters of one or more population. For example, if P is a population proportion of defective items and company claimed that P is equal to 0.1. Now this is a statement made by the company and this is an hypothesis. We call this statistical hypothesis and denoted by H. Let me consider a second example. If mu is an average lifespan of electric bulbs manufactured by a company and company claimed that average life is 1100 hours. That's a statement made by the company and that's an hypothesis. Next, consider this example. Mu1 and mu2 be a true average consistence of different materials. The assertion mu1 minus mu2 greater than or equal to 2 or mu1 minus mu2 is equal to 0 is again an hypothesis. We call the statistical hypothesis. Next, let's see what exactly mean by hypothesis testing and how we do it. We discuss that in the next step. Okay, it is a statistical method used to make decision or draw conclusion about the population parameter from the sample data. Now, how we do this? What we do here is once we formulate this hypothesis, we make use of sample data and we need to draw conclusion from that whether to reject this hypothesis or not to reject this hypothesis. And for that, we need to know the steps involved in hypothesis testing. The first step is we formulate the hypothesis. Okay, we explain step by step later. I go in detail. But the next step is we choose a significance level. And what exactly mean by significance level, we discuss that in upcoming sessions. And third step is we select test statistic. Now it depends on data type and distribution. And once we select the appropriate test statistic, what we do here is we find the test statistic value and p-value, okay, using the sample data. And finally, using this test statistic value, p-value, and significance level, we can draw conclusion about the population parameter. That is about the hypothesis. Okay, if I start with a formulation of hypothesis, first we see that there are two different types of hypothesis which we formulated. There are two competing hypotheses under consideration. First one is a null hypothesis and the second one is alternate hypothesis. Basically, null hypothesis is denoted by H0 and alternate hypothesis is denoted by H1. Okay, this is a standard notation. I'll be using H0 throughout. And next time if I say H0, it's nothing but null hypothesis. Okay, null hypothesis serves as a default or baseline assumption. And the alternate hypothesis represent what we aim to prove or support. That is basically a null hypothesis is tested for possible rejection under the assumption that it is true. Okay, there are a few key features of null and alternate hypothesis or this. Hypothesis test means that it does not prove X0, H0 or H1, but evaluates evidence against H0 under the assumption that it is true. Look at this. When the statement is given, when the assertion is given by the company or manufacturer, we're not going to prove that assertion is correct or false using the sample data. What we do here is we collect enough evidences against this null hypothesis and to support this alternate hypothesis. If the sufficient evidences are collected against H0 from the sample data, then we reject this H0 and we support this H1. Okay, now I'll give some examples after this. Basically, null and alternate hypothesis are logical complements to each other. Okay? If one is accepted, other has to be rejected. Okay. And there's another important thing to note here is H0 always includes equality sign and H1 includes inequality sign. For examples, look at this. If a person encounter a jury trial, then this null hypothesis is defendant is innocent, and alternate hypothesis is defendant is guilty. You can see this when police hand over this person who committed crime and place them in front of a jury. They always wanted to prove that defendant is guilty. Okay, first they assume that this is defendant is innocent, and they collect enough evidences to say that H naught is not true. That is, they reject this and to accept this the statement that he is guilty. Look at this next example. A factory has a machine that dispenses 100 ml of juice in a bottle. The employee believes that the average amount of fluid is not 100 ml. Okay, not 100 ml. It claims that it can be more than 100 ml or less than 100 ml. Look at this. Null hypothesis is assumption, that is mu is equal to 100 ml, which is supposed to be true, which we assume that it's true. But employees claim that what we need to prove here is it is not exactly equal to 100 ml. Okay. From the sample data, what we collected, what we do is we do some testing and gather evidences to reject this one and to support this. Okay. If we cannot find enough evidences to reject this, then we don't reject this one. Okay, that's it. Look at this example. You tell me what is a alternate and null hypothesis for this particular example. A company manufactures car batteries with an average lifespan of 2 or more years. Okay, the company claiming that average lifespan is 2 or more years. An engineer believes that the value is less than that. Therefore, in this case, null hypothesis is average lifespan is greater than or equal to 2, and alternate hypothesis is it is less than 2, right? Yeah, less than 2. You can see this null hypothesis has equality sign and it has only inequality sign. See this? Okay. Next is we discuss types of alternate hypothesis. Okay, there are two types of alternate hypothesis in two different examples which I considered earlier. You can see this. In this case, alternate hypothesis mu is not equal to 100 ml. Now, in this case, alternate hypothesis mu is less than 2. This means that if mu is, if from the sample data, if you could able to prove that if mu is less than 100 or mu is greater than 100, then we can reject this null hypothesis and support this alternate hypothesis. But in this case, okay, sometimes it can be even this as well. I consider this. Okay. Look at this one. This is an alternating hypothesis. This is null hypothesis. Now, from the sample data, if we collect enough evidence to say that mu is less than 2, then we reject this null hypothesis and support this alternate hypothesis. But if we get an evidence to say that mu is greater than 2, then we don't reject this null hypothesis in this case. Okay. Thus, we have two tests. One is a two-tailed test, other one is a one-tailed test. The test of any statistical hypothesis with alternate is two-sided. Something like this, then we use two-tailed test. If it is one-sided, theta is less than theta naught or theta is greater than theta naught, then we call this two-tailed test. Sorry, one-tailed test. This one is two-tailed test. Okay, next we see what exactly is a test statistic. Okay, I mentioned it right earlier in the different steps involved in hypothesis testing. And once we formulate the hypothesis, we need to find appropriate test statistic for that hypothesis what we formulated. It depends on the data type, as I mentioned, and also distribution. Test statistic is a numerical value calculated from sample data. It's a numerical value, that's it. Okay, during hypothesis testing. Now, once we find this numerical value, it can be more extreme. It indicates larger difference between sample data and null hypothesis. If the difference is significant, null hypothesis is rejected. If it is not, then the null hypothesis is not rejected. And basically, it is used to make decision about whether we should reject this null hypothesis or not. Okay. And the value, when you say that it's extreme, it depends on a significance level. Okay, I'll discuss this in the next session in detail. Look at this one, types of test statistics. There are different types of test statistics that depends on data type and the hypothesis we are testing it. Z test statistics, T test statistics, chi-square statistics, and F statistics. If you remember, we discussed in confidence interval. Now we discussed uh, Z, T, chi-square, and F. Remember that, right? Yeah, and we basically use Z when a random variable what we are interested in is approximately normal. That is, assume that my parameter is mean. Parameter is mean, and this is null hypothesis. And for instance, if I consider this as an alternating hypothesis, from the sample data we find mean. That is, X bar is a point estimate to this population mean. And from the sample data, I need to draw conclusion about this population parameter and to check whether this is equal to x naught or not equal to x naught. Now, what we do here is we learn something about confidence interval, right? And we find a z value. If z value lies within the confidence interval, okay, then we say that this value is not extreme. Then we don't reject this null hypothesis. If z value, whatever we find it, is not inside the confidence interval, if it is outside the confidence interval, okay, then we say that z value is extreme, and we reject this null hypothesis in support of alternate hypothesis. Okay. If n is not significantly large, then population of that is x bar, distribution of x bar need not be normal. In that case, we considered a t random variable. Okay, in the second case of confidence interval, and the corresponding value, whatever we find, it is called a t value, the t test value in this case. And for variance, we use chi-squared statistics, and when our parameter is ratios of variance, we use F statistic. Look at this example. The question here is to formulate hypothesis and calculate appropriate t statistics. That's it. Okay. That is, a factory has a machine that dispenses 80 ml of juice in a bottle. The employee believes that the average amount of fluid is not 80 ml. Oh, this is an example which is quite similar to the previous one which we discussed. Okay, null hypothesis is mu is equal to 80 ml, and alternate hypothesis. Okay, in this case, to be more particular, if it is greater than 80 ml, it's not a problem to the consumers, right? We consider alternating hypothesis as less than 80 ml. If it is less than 80 ml, then there's a problem with that. If it is greater than 80 ml, not a problem, right? Therefore, this comes under one-sided, not two-sided. Using 40 samples, E measures the average amount dispensed by the machine to be 78 ml. Okay, what do you mean by this? You take 40 samples, that is, sample size is 40, and found amount of juice in each and every bottle after taking 40 bottles, and it took that average to be equal to 78 ml, which is x bar is 78 ml. Okay, and standard deviation of this distribution, sigma x bar. Okay, is that sigma x bar? Yeah. This is standard deviation, S square, sorry. S square is 2.5. Oh, S square, not X square. This is S. Square root of this. S is equal to 2.5 ml. Okay, we have this information, and I need to find Z value. We see this, N is sufficiently large. Therefore, distribution of X bar is approximately normal. The corresponding Z value is this. Okay, statistic is this. Okay, test statistic is z in this case, which is equal to x bar minus mu divided by a population. A standard deviation is not given. We can make use of this itself. S square divided by s divided by, right? S divided by a square root of n. Have this. This is okay. And corresponding z value is this, and z value is this, or I can say this test statistic value. And test statistic is z. Okay, z test statistic value is small z. This is equal. I can replace this random variable x bar by this particular value 78 minus mu. What is mu? Mu is 80 ml. Okay, that's the time, right? By the company 80 ml divided by 2.5 by square root of 40, which is minus 5.06. Okay, I got the test statistic value, and how to conclude this I have given it in detail. I discussed this in the upcoming sessions. We know that if my interest is 95% confidence interval, we know that if it is one-sided, or I consider this to be one-sided, okay, no problem. Okay, I consider one-sided, right? Okay, let me put this. This is a z distribution, and this mu is equal to 0 in this case. Okay, I find z value for 95% confidence interval. I consider this as z alpha. Alpha is 0.05. Remember this 0.05. That is this leaves the area 0.05 to the right, and to the left it's 95 because it's one-sided, right? My problem arises if this is less than 80 ml. I want this. I reject this. Okay. Okay, this less than 80 ml, not greater than 80 ml. Okay. Okay, if I consider this to be not equal to, I'll come to that one-sided later in detail. Okay, I just consider this diagram. Don't clean this. Okay, this is z alpha by 2. This minus z alpha by 2. If I consider this to be a 95% confidence interval, and this point will be a minus 1.96, and this point is 1.96. We can say this minus 5.06 lies somewhere here, right? Which is extreme. Okay, it's outside this confidence interval. From this, we say that the population mean, whatever we have, that's significantly far away from this sample mean, because test value is at minus 5.06. Therefore, what we do is we reject the claim that mean is 80 ml. Okay, we support this mean is not equal to 80 ml. Hope you understood this. Is that correct what I said? Yeah. Okay, thank you. We discuss more in the next session.